STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Sam James.
Welcome to this week's episode of NASA STEM Stars, the 8th in our series. I'm Jen Hudgens, coming to you from the Kennedy Space Center. I'm an education specialist out here working with the Office of STEM Engagement with the Next Gen STEM project, where we push out curriculum and exciting new activities for teachers and students all across the country and the world. The NASA STEM Stars webinars is a chance for all of us to get together and get to know some of our STEM stars that actually work behind the scenes at NASA. They could be engineers or biologists or doctors or astronauts even. So today's special guest is Sam James. He comes to us from Langley Research Center, and he actually works in the model fabrication building or factory, and he is an engineering technician. So without further ado, I want to introduce you to Sam James. Welcome to our show, Sam. How are you today?
Wonderful, wonderful. Thank you, Jen, and the NASA for having me on this platform to share my journey, my career path, and what I do at NASA Langley. It's been a joy. I'm from Elizabeth City, North Carolina, which is in the northeastern part of North Carolina, and about 49 miles from Kitty Hawk, when the Wright brothers first took flight. I also graduated from Northeastern High School in 1983, Elizabeth City State University in 1987 with a Bachelor of Science degree in Industrial Technology with a minor in electronics.
Wow, it sounds like you've got a lot of education under your belt there. Took you some time to get all that there. Did you know when you were a kid that you were going to work for NASA someday? Models? Because I'm sure a lot of our students that are watching have probably built like paper rockets in their classroom, or maybe even a model that they launched outside, at some point in their lives. Did you do something like that when you were younger, or did it just kind of develop over time? Tell us how you got to where you are today.
Yes, I did a lot of that, and it's funny that you're bringing it up. Around that time, as a middle schooler, I was making a lot of model airplane out of balsa wood, but I started making airplanes out of paper first, notebook paper, 8.5 by 11 inches. And one of the most important things when you're making these paper airplanes, you're actually folding half of the paper even. So when you finish making your airplane, it has to be balanced. If the paper airplane is unbalanced, it's not going to fly properly. And it's funny, as I got older and then got into what I'm doing now, which I'll talk a little more about model fabrication, is that the moments of inertia of an airplane, it has to be checked and make sure it's balanced so it'll fly properly. But I had no idea that I would be at NASA. That wasn't even on my radar.
Let me remind the students that they can actually ask questions for you, because this is a live webinar. So if they have any questions for you along the way, they're welcome to type them in the chat box and we'll answer them as they come in. So go ahead and continue and telling us about your middle school or what happened when you got to high school.
Okay, so middle school is really when it really all got started. I was very inquisitive. Then I was starting to wonder, what will I be doing? Which I had no idea. I love math and science. I love building, constructing things. I love taking things apart, dismantling things, and putting them back together. This gave me an understanding how things work and understanding how each part complementary to that device or whatever I took apart, radio or whatever was a dryer, which I took apart my mom's dryer one time when it broke. I never got it fixed, but I understood about the electrical cord and how it ran inside and connected all the parts. So that got me spinning there, and I was like, okay. I was building tree houses. I was making things out of bamboo. So this really geared me up with using math and science with this. I was like, wow, I wonder what I could really create. So we were challenged one day by my homeroom teacher at middle school, what career we want to pursue. I had no idea. So what I did, I used my guidance counselor. So I told her what I like, math and science. I love building, constructing things. And then she said, well, Sam, why don't you go in some form of technology? Because by the way, new technology fascinated me. The changes that have been made from now when I was in middle school. I mean, from then when I was in middle school until now, it's amazing how technology has changed. So what's happening now as technology changed practically overnight, so more jobs are opening in technical careers. So therefore, I had to establish a foundation in STEM, is which my guidance counselor did. So she devised a high school curriculum for me where I took all my higher math and sciences.
Wow, that's great that you had a guidance counselor that was really involved in your future and your interests and was able to guide you to that. So if students didn't have a mentor like that, where do you think they could go to find resources on, if they have these interests? You think they probably webinars like this, or where else do you think they could go?
Yes, you brought up a very good point, Jen, because back then we didn't have the resources. I didn't have the resources. And we all think, I thought about, the fire department or, even forensics, which I wouldn't mind, crime scene investigators, because I love solving puzzles. I love solving problems. But we didn't have a lot to go on. But when the guidance counselor told me technology, I did my own research. Now, a lot of the kids today don't know much about encyclopedias, but I use my encyclopedias and start going through different types of technologies that are out there. And then, so when I saw it, I said, wow, I could be in that type of industry. But I didn't know much about the research industry until I got eventually with NASA. But again, NASA was not radar. What was happening with me, I was establishing the foundation in STEM with NASA not even in mind. But it goes to show you that it covers a lot of technical careers by having that foundation.
Yeah, we've had a question from students. What classes should they take in school to prepare them? So do you have maybe your favorite classes that you took in high school? Or
I actually have some classes up in high school. I have a slide up when I was in high school, and you can pull that up if you like. Basically showing you the key STEM courses and classes that I took. Advanced biology, your algebra, your geometry, trigonometry, your physics, and your chemistry. These type courses solidify a lot of technical careers. Now, some careers, like when you attend college, you start getting more into your career. Like let's say for instance, electrical engineering career versus mechanical engineering career. You're basically taking all the same math and sciences like physics and chemistry, but when you start getting deep into your major around your junior year, then you start taking different classes between electrical and mechanical engineering.
Oh, wow, that's probably very helpful to students that are in high school trying to think, what do I do when I get to college? So did you have a guidance counselor that said, okay, you've got all these great background or good foundation, so to continue to pursue, were they able to help you, or was that a counselor at college that started to help you with that step?
Well, I tell you, going back to middle school, the counselor there really helped me when she devised the higher math and sciences, because I also took drafting, and then they call it technical drawing 1 and 2. Mm-hmm. And a lot of the students who are on now, middle school or high school and college students may know, but drafting then was using your mechanical pencil, your T-square architect scale. Well, you call it computer-aided design now. That's what you call CAD. But believe it or not, I saved all those drawings back from 1980, 81, 82, 83. I have all of my mechanical drawings that I took because it meant a lot to me. And to see the changes from drafting now to like computer-aided design, you have additive manufacturing, 3D printing. So we actually 3D printing small models now, or mid-sized models. So basically you 3D printing the parts, and you attach the parts, put them together using certain mechanisms.
Cool. So we do have some questions about what it's like to work at NASA. Do you want to go into a little bit about what you actually are doing?
Yes, I sure will. Matter of
Thanks.
fact, July 7th will be 33 years I've been at NASA Langley. I started at 22, and I can go back. Let me go back to my junior year in college when I applied for NASA with the Office of Personnel Management.
I
I
love
just
these old pictures of you, by the way, Sam. They're just great.
was in
I love
college.
them.
There's a shot here. Matter of fact, I remember this picture very well. A friend of mine who was a photographer, she said, "Hey, Sam, can I take some pictures?" She had a photography class, and she was going around the campus taking pictures. I said, "Sure." And so that was right before my physics class, believe it or not.
Wow.
But yeah, but back to the 3D printing and preparation. My guidance counselor really prepared me by taking my higher math and sciences. Granted, a lot of those courses in high school weren't college courses. Now, I think now, this day and time, you can take college courses in high school, or you can transfer it. I had to retake all those classes back over in college. You know, your algebra. Well, I think I took my trigonometry. I think I took over in calculus. I think I had to take over. But I know the drafting, technical drawing 1 and 2 was very helpful, because when I started getting into my major, I took engineering graphics 1 and 2. And I noticed that a lot of my classmates didn't have that in high school. And I became the assistant to the professor, because I knew about all the mechanisms and the tools and the devices to use with drafting. So I was helping him teach the class.
So it's like the CAD programming and 3D printing that the students have available to them now may be a really valuable resource, and that they should kind of dig into that a little bit more if they're interested in a career path like yours, right?
Yes, it's very valuable.
Yeah.
And also, if you want a technical career, or in aerospace, mechanical, electrical, whatever the technical career may be, what you want to do is ask yourself some questions. Do I like math and science? Do I like figuring out or solving problems? Do I like critical thinking? Do I like doing my homework, getting good grades? It's that simple. Do I have my desire? Is your desire there to do well in whatever you do? So you have to ask yourself these questions to find out what type of person you are, what you may like.
Yeah, what motivates you, right?
And what motivates you. And it goes back to your hobbies, even your interests, or what you like and all. And then you'll be surprised how you can tie that into what your career may be in the future.
Can you share what your hobbies are? What are you interested in when you're not working at NASA?
The audience see this. You can pull the slide up of my hobbies and interests.
Yeah.
And believe it or not, over time, my hobbies and interests have changed, because I was more into sports. I played a lot of sports. In high school, I played baseball, soccer, and football. In college, I played football. Matter of fact, that's my senior picture there, the high school soccer picture. But
See, I know we have a slide at the beginning that shows some of your other interests in soccer.
yeah,
And
there
we
it is.
go.
So believe it or not, I have acting, a little modeling in here, and of course arts and crafts, and I love to cook. So I had too many hobbies to list, Jen. But my hobby, as I got older, my hobbies changed. So back in the mid-90s, I got into modeling. Someone's approached me about modeling, and I didn't know much about it. I've seen stuff in the magazine. I said, well, let me think about it. They gave me time to think about it for like a couple of weeks. And I say, shucks, why not? So actually it was someone from Wilhelmina Models, and I'm still with them for 22 years. I've been with them. So I do stock photography. And believe it or not, I started out doing a runway for department stores, walking the runway.
You have a diverse background, Sam. My goodness.
And then I got into the print work. I did stock photography for a couple of photographers. Which you can see the picture anywhere. It can show up anywhere. One of my college professors contacted me one day and said, hey, I was walking in an airport in Honolulu, and I saw a big picture of you in the airport in Honolulu. So that was pretty cool. So also in my acting, after modeling, I got into acting more. And believe it or not, I was in acting in high school. I was in the drama club in high school, and also I was in drama in college. So I had no idea that this would follow me to this point. So I actually started doing reenactments for the Interpol Investigates, which is it's a picture of that on the Hobbies and Interests, but it was for Interpol Investigates for the National Geographic. It's down in the right-hand corner, and I was playing a sheriff, and I was solving a crime, and these are actually real crimes that happened back in the past. I think this was happening in the early 80s in Blacksburg, Virginia. And the two people had went overseas. They left the U.S., went overseas. That's why they call it the Interpol Investigate. So they had to go overseas to track them down. And I was playing the sheriff. I was doing everything. I had the gun that picks up the blood and all. We found all of that in the home. So I was going through all of that. And then I did the New Detectives on the Discovery Channel and the FBI Files. So that was pretty cool to do that too.
So your interest in forensics when you were like in middle school has come back to haunt you a little bit, right?
I thought about that though, but I could have seen myself going into forensics if I wasn't at NASA. I could have gone in forensics because I love solving problems and doing puzzles and solving crimes and stuff like that.
Well, it sounds like being well-rounded. You had a lot of not only sports, but other types of extracurricular activities and interests in addition to your academics. So would you offer that as good advice for students to not just hit the books hard, to also get out and enjoy life a little bit?
I would say they could hit the books hard, but also have time for I would say fine arts, because I didn't mention I learned how to play the trombone, which is up there on the Hobbies and Interests. I learned how to play the trombone in the 7th grade. And my big problem with that, when I started playing football in high school, I couldn't be in the band and play football too. So that was a problem. So I ended up getting out of band and going into playing football, and the band director was upset with that. And because my brother was behind me, 2 years behind me, and the band director approached him and said, I think Sam was hanging around the wrong group. And then my brother said, no, Sam does not hang around the wrong people. Sam does.
All right, we've got some questions coming in about your work at NASA. So why don't you jump in and tell us what you're working on, what missions you're working on now, what models you've made in the past or currently?
Okay. Yeah, I have a slide of that too, the models that I've worked on. Let's see, in 2000, early on in 2001, I put this picture up here because it's my favorite of the 757. Started in 2001. It was for a program called Refuse to Crash, and they wanted to cut back on aircraft fatality by 95%. The reason why I like this particular airplane rather, it has two small jet engines that produces 20 pounds of thrust, so it can get up to 200 miles per hour. But the pilot never pushed it to that point. He'll go to like maybe 100, a little over 100 miles per hour. It was the test speed. But this model here, what was so challenging with it, we had to keep the weight down. I think the total weight was 58 pounds. So we had to use a honeycomb, what we call a honeycomb core, about half-inch honeycomb core. It's man-made. And of course, they get the idea from a bee's nest. And they found out that the structure of this could be they can make this very strong and hard to compress, but yet lightweight. So we have a honeycomb core, as you can see in the left-hand corner of the model. You can see the aircraft structure support, and then you can see the two halves bonded together. And then you have the engine nacelles, which I had. That was my job with this model: do the engine nacelles and the fuselage. So we have another team doing the wing, So we had different parts. When we work on teams, we had different parts to produce. And it took us about 3 months to finish that, but we were working 2 shifts because they wanted really quickly.
Do you have a favorite model that you've made?
This this is one of the favorite ones. I have the 1% blended wing is pretty cool too. And I also like, in this same photo, the inflatable airlocks. You have 2 subscales there. And basically they're doing this to prepare going back to the moon and to visit Mars. But the idea with these are actually called soft goods. And the reason why they want to go this route, because it's easy to fold and stack in a space vehicle, where a hard shell will have more weight. So if you use a soft good shell, you could take it up in space and then blow it up once you get up there. Like you see there, from the lunar rover going to the habitat where the astronauts will be living in. I basically call it an inflatable hallway, but you have different uses for this, as you can see and on the slide. They can use it for a hospital or crew cabin or freezer. So you could have multiple uses for this. But the idea of the thing is to be able to deflate it and inflate it at any time.
Is that a mission you're working on currently, or what are you working on right now?
I finished that about a year and a half ago. I spent almost 2 years working on that, believe it or not.
Oh, wow.
So recently, before the COVID-19 happened, I was working with the acoustics group at NASA Langley. They're working on noise reduction on jet aircraft. Mm-hmm. So noise reduction. So right now I'm in a pause on that. So when I do go back, I have to pick that up, continue working on acoustic panels.
Is that with the X-59 plane, the sonic boom?
Yes, planes like that. Because with the sonic boom, if you remember the Concorde, it only flew over water because the boom was so loud it could shatter the windows in skyscrapers.
Yeah, we've got another STEM Stars episode that talks about some engineers that work on that project. So if the students are watching, you can check that one out next if you guys are interested in that topic. You've got another slide there that's got some other models that you've been building.
Models, yes, you can pull that up. It's the 1% blended wing body. Back in the early 90s, I worked on, this is another favorite model. When you just asked me that question, I didn't think about it at the time, but 1990, this project here was for Boeing. NASA was doing the research in conjunction with Boeing. Okay, the white model in the far right corner is a 5% scale. We made 5 different scale models of the blended wing body. And the reason why we make different scale models is because they've flown in different wind tunnels. All wind tunnels have different capabilities and all. They look for different things. So the 5% scale, the white model all the way to the right, that was designed to hold 800, I think maybe 650 to 700 passengers. So it's going to be a double decker. So when they tested in the wind tunnel, they found out the weight would be a serious problem with the luggage and the fuel. So they redesigned it for 450 passengers, which is in the lower right corner. It's designed for 450 passengers. And you think about going back to the paper airplanes. This is what I was telling you about. Going back to the paper airplanes. So a lot of you students out there that y'all were becoming engineers and didn't even know it. Because when you make an airplane, you got to understand what you want the airplane to do before you start designing it. You say, well, if I want a glider, you want more wing area. If you want something really fast, you want less wing area and more of a pointed nose, so it go further and faster. So this is the same thing with research. And they found out, well, the weight will be a problem, so they redesigned it. And you notice they raised the engine nacelles higher on pylons on the 450 passenger one versus the 650 passenger airplane, where the engine nacelles are more embedded in the back of the airplane. You look at the difference of the designs.
So you made a good point there about the paper airplanes. Normally when you make a paper airplane, you throw it. Right. Well, you can't throw these giant models, so you use wind tunnels, right, at Langley, and you put your model in the wind tunnel. So instead of throwing it, you throw the air at your model, right? Is that pretty much how it works? Exactly.
Again, you're close to it. You're close. You're right on it. But basically what you're doing with wind tunnels, you're simulating full-size aircraft or airplane in motion. So we're doing this in the wind tunnel, and then basically we're producing the speeds that they need to test this airplane. Just like takeoff and landing, all of that was done in the wind tunnel. So if you wonder why you sit on the runway for a little bit, wonder why you're waiting around. Well, you have to wait for the previous airplane get out of clears out, because the weight from the wingtips of the airplane could affect the airplane that's coming behind it, and it could cause an accident. So all of this is simulated in the wind tunnel.
So does Langley, is that the model shop's unique to Langley, or do you think, does NASA have other centers that use wind tunnels and models like you all there?
Yes, they do. They have other NASA centers. There are 10 different NASA centers. But what's so unique about NASA Langley, it was the very first NASA center that was established. And it was NACA back in the 50s or 40s or 30s, 40s, and 50s before they changed over to NASA, NASA. Back then, they were making their models out of balsa wood, and they were sealing it with resin. So that was, I'm glad you brought that up, Jen, because when I started working there, I saw pictures, old pictures, and I noticed the change in technology as I've been there 33 years. You see the change from making balsa wood to making airplanes with fiberglass and graphite with unique materials. And then now you're seeing the change with 3D printing and making airplanes using additive manufacturing. So the technology, like I was saying earlier, having that STEM foundation really helps you be prepared when, jobs in technical careers open up, like this. That's why it's so important now. So you're working on your future for tomorrow now, basically.
Yeah. Are you ready to give the students a challenge and get them on to maybe building a model of their own?
Yeah, sure.
All right. So we've got a challenge for the students. It's actually building their own space habitat, similar to what you were doing with that cloth, like you said, hallway for the lunar habitat.
Yeah,
so students can take materials from around their house, recyclable cereal boxes or 2-liter bottles, and actually create their own moon habitat with the stuff that they can find around their house. So we want to challenge the students to build their own space habitat and then share with us on any social media platform that they choose, just using that hashtag NextGenSTEM. And I also want to make sure that the students know that you have your own Twitter account, and they can continue to follow you and see what your projects are that you're working on. So you can see down there Sam's Twitter handle. And I'd make a note of that because I believe you said you post pretty often about what you're working on.
Yes. And I just established that Twitter account a few weeks ago just to, help the students involved in STEM or want to know about STEM. And I said, well, I'll tie that into what I do. I wasn't a big social media person, but I said, well, I can do this for, the STEM students who are interested in STEM and try to be a beacon or advocate for them as much as possible, for a successful future for these guys in any technical careers.
All right. Well, I want to encourage them to reach out to you then and stay in touch with you.
Yes, they could touch base with me on the Aero Model Maker Twitter handle, or they can email me. You could give them my email, my work email. I'll be more than happy to answer any questions they have.
Sounds good. Thanks so much, Sam, for spending the day with us. And I want to encourage our viewers to stay tuned next week. We're going to start a whole new series on the James Webb Telescope. And our first episode will be next Thursday at 2 p.m. Eastern, right here on NASA STEM YouTube channel. Thanks again, everybody, for tuning in. And thanks again, Sam. It was a great meeting you, and hope to see you again soon.
Thank you very much. You're very welcome. And
All right, bye, everybody.
Have a great weekend.